Everyone, I'm back again with another video. In this video, we are going to do quicksort. Now, as we did in the merge sort topic, this topic is also going to be a two-part video. This is the part A, the first video on the topic, in which we are going to talk only about the algorithm of how do we do merge sort. Now, before going on further in the video, if you don't know how recursive function works, or if you haven't checked out my video on recursion, I will link it in the description box below, and make sure you check the video out and get the whole idea of recursion before going on further. Now let us dive straight into the video. Now quicksort. Quicksort is another sorting algorithm that sorts the array in ascending or in descending order. Now before going on into the algorithm, some bullet points about quicksort. It is an efficient sorting algorithm. Quicksort is very efficient sorting algorithm because the time complexity as well as the space complexity of quicksort is very low. Second point, that if implemented well, it can be 2 or 3 times faster than merge sort and heap sort, and which is a very good thing. Third point is that it is a comparison sorting algorithm, and what does that mean is that we compare every element in the array with a pivot element, and what a pivot element is we will see in the further part of the video. On average, the worst case is somewhat equals to O n log n, and I know guys that I've promised you that I will make a whole playlist on how to calculate the worst case of sorting algorithms and other algorithms, and I will put the whole playlist as soon as possible. But for now, just memorize that the worst case is O n log n, which is somewhat equal to the merge sort algorithm. Fifth point, that it is a stable sorting algorithm, and what does that mean? For example, that this 2 is present in before this 2, as we can see. Now after sorting, this 2 will always be present before this 2, so it keeps track of the position of the element, so it is a stable sorting algorithm. Now we will look at what is a pivot element. Now if we've given an array, the last element is always the pivot element of the array, and what does pivot element do is that we will loop through the array from first position to the last position, and whenever the value of an array becomes less of the value of the whenever the value becomes less than the pivot element, we swap. Now I know this is a lot, but just forgive me for my mistakes here and here. But now just see this array that we have given is 8 2 8 7 2 4 3 and 5, and now as I told you that the last element is always the pivot element, we can also make the first element as a pivot element. But most of the times when you see this algorithm, you will see that last element is considered to be the pivot element. And what does the pivot element do? You will see here. Now we will make two variables, j, which is pointing to the 0th position, and I, which is pointing to one less position than j, that means -1. As you can see here that j is pointing to the 0th position, and I, which is pointing to the one less position of j. Sorry. Now we will loop through the array, and whenever the value of an element become less than the value of the pivot, we will swap. Now as you can see here that whenever the value of the element at j becomes less than the value of the pivot element, we will first increment I and then swap and then increment j. And we have to do this till this value, a value less than the pivot element. We'll have to do this till the value is less than pivot element. For example, the pivot element is at the 6th place, so we'll have to iterate the array till the 5th element. And how we does this is, first j is pointing to the 0th position and I is pointing to the -1 position, so means I is pointing to nothing. Now as 2 is less than the pivot element, so what we have to do, first we have to increment I and then swap. Now as 2 is less than 5, we increment I and then swap. Now I is incremented to the same position as j, so after swapping, the position of both the elements remain the same. First the ith position get incremented and we swap the element at j position with the element at I position. Now j and I is pointing to the same value, so after swapping it becomes the same. Now I is pointing to the 0th position and j is pointing to the 0th position. Now j get incremented. Now after j get incremented, as I told you that I is pointing to the 0th position and j is pointing to the first position. Now 8 is greater than 5. We will do nothing. We will just increment j. Now 7 is also greater than 7 is also greater than 5. We will also increment j. We will do nothing. Now as 2 is less than 5, first we will increment I. Now I gets incremented and we will swap the position of now the elements at the position I and j. J is pointing to the fourth position, j is pointing to the second position, and I is pointing to the eighth. J is pointing to the third position whose value is 2, and I is pointing to the first position whose value is 8. So we will swap 8 with 2. After swapping, the array become like this. Now j is pointing to the third position and j gets incremented. After incrementation, we see that 4 is less than 5. As 4 is less than 5, first the I gets incremented and then we swap these two values. Now after swapping these two values, the I is first pointing to here and I is first pointing to here and j was first pointing to here, and then j get incremented. Now as I told you that whenever the value is less than the value here, we'll just increment I. Now I get incremented and I is pointing to here, and then swap, and after swapping the whole array becomes this. And what I told you that j will only get incremented a one less position than 5. Now j is at that position. Now what we do when we reach the final place, we just increment I and then swap the pivot element and the ith element, and after swapping the pivot element with ith element, the final array becomes like this. And what we do here is that we give the position of the pivot element so that even after the whole array is sorted, the position of the pivot element remains the same. And you can see that in the left side of the pivot element, every element is less than the pivot element, and on the right side of the pivot element, every element is greater than the pivot element. And this is very useful for the sake of this algorithm, and we will do, and we did this all this looping to create an array in which before the pivot element every element is less than that, and after the pivot element every element is greater than the pivot element. So I hope so that you will get the whole idea of how to create a partition array. If you're not, I'll tell you again in fastly that you just have to compare the value of j and the pivot element. If the value at j is less than the pivot element, we just increment I and then swap the elements at the jth position with the ith position and then increment j. Now I know this is a lot to grasp at first sight, but if you hold on with me for more than 5 minutes, I will make sure that you will get the whole idea how this algorithm works. Now as I told you that this is an algorithm. As you can see here, there's a function which is accepting our array, the first position of the array and the final position of the array. It is testing a condition that whether or not the first position is less than the last position, and if so, it is implementing these three functions. First is the partition function, which is this whole function. We have to create a partition array, and third and fourth are the recursive function that is pointing to this function, as recursive function does. Now first we are passing this array 2, 8, 7, 2, 4, 3, 5 to this function. The first position is 0 and the last position is 6. P is the first position and last position is R, which is 6. Now when the compiler reaches here, it solves, a quicksort function is being added to has to be added to the stack, which has an array A, this array, the value 0, which is pointing to the first position of the array, and the value R, which is pointing to the last position of the array. It gets it added to the stack. Now first let me get my drawing tools and I'll tell you in a good way. I'll make enough to make. Okay, now whenever the compiler reaches here, it adds this function to the stack. Now this function gets this array, this p value and this r value. Now imagine that there is no other function in the stack. You have to imagine, in every recursive algorithm you have to imagine. It's very important for you to imagine. Now just imagine that there is no element, no function in the stack, only this function is being added yet. Now the function have the array A, the value 0 and 6. It goes down and check whether 0 is less than 6. That is true. It goes here, and and this function gets added to the stack, which is the partition function, which turns out the array into this into this into this into this array, which has a partition value at fourth position. Now whenever this function get added in the stack, the compiler goes down and sees, oh, quick sort is being called again. It goes down, it goes back again, and the values which is passed is the array A, the value P, which is the first position, and the value Q minus 1. Now Q is 4 and Q minus 1 is 3. So this array is being passed to the function again. So this function gets added in the stack. Now this function gets added in the stack. It goes down. It checks whether 0 is less than 3, as P is 0 and R is now 3. Yes, P0 is less than 3. Now it goes back down, and this array is then further created into a partition array, which is this array, in which the Q value is 2. Now it goes down here and gives and sees that quicksort is being called again, but the values which is being passed is the array A, the value P, which is 0, and the value Q minus 1, which is this array. This array is being passed to this function again. So this function gets added in the stack. As this function added in the stack, the function goes down here. It checks whether 0 is less than 1, and it is true. It goes down here and forms the partition array. Now the formed partition array is this. Now the formed partition array is this, and now the formed partition array is this. It goes down here and solves, oh, that the merge sort is being called again. So it goes back here, add this to the stack, add this to the stack, add this function to the stack, and sees whether 0 is less than 0 or not. And it says that, oh, 0 is not less than 0, 0 is equals to 0. So it returns nothing. So this function returns nothing. As this function returns nothing, this is the first time that this function is being completed. So it is the first time that the compiler goes down here and give the value plus one greater value than the pivot. Now there is no such value present, so this function also gets completed, and the whole function, this function also gets completed, and the whole function gets completed. Now as this whole function gets completed, you can see here that this partition array till this point is being sorted. Now as this function gets all this function gets completed, the control goes back to this function, and you can see that all of these three values is being sorted. That means this function is sorted. Now it goes back here and give the array which having the one greater than value than the pivot element, which is this 4 element is being passed to back here. Now as it is passed here. Now the values which is being passed is A, 4 and 4, as the index value is 4 here. Now as it goes back here, it says 4 is not less than 4, 4 is equals to 4. So this function will return nothing. As this function will return nothing, this array, this method is removed from the stack. Now you can see that all of this method is being sorted. Now as all of this method is being sorted, this partition method gets completed. So this quicksort method is being completed recursively. Imagine it that this quicksort function is being completed. So this part of the array is being sorted. 2, 2, 3 and 4. This part is being sorted. Now as this part is being sorted, the compiler moves back here, and the compiler, when moves back here, it will give the one greater value than the pivot element. The one greater than value of the pivot element which is being passed is this. So the control flow goes back here and it checks that 5 is less than 6, which is true. It goes back here and forms the partition array, which is this, as 7 was the pivoted element, and after partition the array which is formed is this. It gives the one less than position to the quicksort function. So it goes back here. The values which is being passed is array 7 and 5 and 5. The values which is being passed is 5 and 5. as this function returns nothing, the control flow goes back here, and you can see that after this there is nothing. So this function will also return nothing, as this function will also return nothing. This is our sorted array. So this sorted array gives the value back to this array, and now you can see that our array is being sorted, and when our array is being sorted, this function gets completed, and when this function gets completed, this function also gets completed. Now as you can see that we got our sorted array. So this is how the quicksort algorithm works. It is nothing but we will create a partition. We will give all the values which is before the partition in one quicksort recursive function, and all the values which is after the partition element to the other recursive function, and we'll do the same thing again and again, and we'll get our sorted array. Now so that's all for this video. In the next video we will write the code of quicksort, and I will upload it as soon as possible. Hit thumbs up if you like the video, or if you want to support the channel. Well, there are a couple of ways you can do that. First, you can share the video if you think that this video is helpful for someone. Secondly, you can subscribe to the channel, as I upload regularly on programming algorithms. And thank you so very much, and I'm very happy Diwali.